Good evening everyone and welcome to the Q&A session 18 from the chapter of motion in a straight line. The topic is the concept of relative velocity. So we will try to understand this topic with the help of this question. So the question here is: a boy holds an umbrella at 30 degree with the vertical to prevent the raindrops falling on him. So this is the figure which I have already drawn here, and with respect to this question, now the raindrops hit his head vertically downward when he starts running towards the east at the rate of 10 km per hour without the umbrella. That is, he has thrown the umbrella. And now he is running towards the east with a speed of 10 km per hour. So we have to find the speed of rain drops with respect to the road and with respect to the moving boy. So here I have already drawn one figure, and this is the position of the boy, and he is holding this umbrella at 30 degrees with the vertical. So this is the east, this is the west, so this will be the north and this will be the south. Now the raindrops hit his head vertically downward when he starts running towards this east, that is in this direction, without the umbrella. That is, he has thrown the umbrella. So we have to find the speed of the rain drops with respect to the road and with respect to the boy. So here the velocity of the boy with respect to the road, I'm just depicting here is this velocity as VBR. So the velocity of the boy with respect to the road is denoted here as VBR, and its direction is towards the east as shown with this arrow. Now when he is running towards the east without the umbrella, and the raindrops are hitting his head vertically downward. So the velocity of the rain with respect to the road, VRR, will be along the direction as shown by this arrow. And so here what I will be doing is I will be making one vector triangle. So this is the vector which is representing the velocity of the rain with respect to the road, and there will be one vector like this. This is the velocity of the boy with respect to the road, and this vector, this is the velocity of the rain with respect to the boy. So this, if this angle is 30 degree, so this angle will be 30 degree. So here from this vector triangle, the velocity, we have to find the speed, or you can say the velocity, because here in this case the speed and the velocity are the same. So here the speed of the rain drops with respect to the road, that is the speed of the rain drop with respect to the road. So we have to find VRR. So VRR will be equal to this VRR, that is base upon hypotenuse. This is equal to V upon VRB. This is equal to cos theta or cos 30, and here VBR is known to us. V, that is the velocity of the boy with respect to the road, is equal to 10 km per hour. So from here, instead of using the cos theta, we will use the tan theta, the formula for the tan theta. So tan 30 will be equal to VBR divided by VRR, and this is what we have to find, that is the velocity of the rain with respect to the road. This is equal to VBR. Now VBR is equal to 10 divided by tan 30. So tan 30 is equal to 1 upon root 3. So this will be equal to 1 upon root 3. So this is equal to 10 root 3 km per hour. So the velocity of the rain drop with respect to the road is equal to 10 into root 3 km per hour. Now we have to find the speed of the rain drop with respect to the moving boy also. So this is the VRB is the velocity of the rain with respect to the moving void. So this can be found by using the this sine 30. This will be equal to VBR upon VRB. So by using this formula, we can find the value of the velocity of the rain with respect to the this moving void. So VRB, this will be equal to VBR, this is equal to 10 divided by sine 30. Now sine 30 is equal to 1 by 2. So this is equal to 20 kilometer per hour. So the velocity of the rain with respect to the moving void, this is equal to 20 kilometer per hour, and the velocity of the raindrop with respect to the road, this is equal to 10 root 3 kilometer per hour. So thank you very much for joining this session. In the next session, we will be continuing with the same topic, that is the concept of relative velocity. But in the next session, I will be coming up with a different type of a question. So till then, have a nice day. Bye.